Hey folks, in this video we're going to learn how to remove a node from a linked list. Now, similar to the case of adding a node, we're going to do kind of the simplest possible case, which is adding to the front of a list. Now, we've already seen a few things, right? We've seen how to add a node, we've seen how to traverse an entire list. So remove is kind of the last thing we need in order to be a fully functional linked list with some useful functionality. So what's the idea? We have a list, and this list basically has a bunch of nodes in it, and what we want to do is remove that frontmost node. Now in this picture here I have, of course, the same list we had before, which was the one containing 3, 7, and 2. So this is basically what I would start with, is this list over here. Now my goal, right, is this over here, which is basically just dropping out that first node. So how can we implement this feature? This feature is actually pretty straightforward. All we do is basically take front and redirect it to know not about 3, but about 7, right? I want to have this over here be my new front. So this is actually like one operation here, right? That's one operation. There will actually be a second operation that's specific to C, which is to deallocate that node as well, right? That'll actually be kind of a step 2. This is something that'll be new, and you won't have seen if you've worked in a language like Java before. Okay, so this is the plan here, right? We're going to basically write a little bit of code, right, to update front to ignore the first node, and then also we'll write code to basically free the memory behind that first node. Then in the end, right, we'll get this picture over here. All right, so that's the plan. Let's jump to NetBeans and try writing a function to remove from the front of a list. Okay, so here we are back in NetBeans. Let's see what we want to do. We want to, of course, implement a function which removes the front of the list. So let's see. I'm going to put it over here. I'll put it next to the add front because it kind of goes together. So let's see. I want to have something called basically remove front. What should I take in? Well, probably I'll just take in the front of the list. So I have this return type. This function will actually have kind of the same problem as our first one, where we had to add a return type. Otherwise, we couldn't see the changes in the outside. So let's actually go ahead and do that. We'll have this as being basically that return. So let's see. We have this. This should be fine for our method signature. What needs to happen? Well, we had kind of two steps. One was to basically update front, and the second was to free the memory that node is occupying. Now, one step that you might think about doing is the following. Typing front equal front next. This is the correct code for getting rid of a node, right? Basically forgetting about it at the front, but it's not really what we want. There's two problems with it. First of all, it assumes our list is not empty, and second, we won't be able to deallocate the memory for the node in front. So how do I fix those two problems? First, I'm going to make sure this only runs if I have a non-empty list. So if front not null, then do this stuff over here. So I'll do that while front not equal null. So that only runs there. Okay. And let's see. So front isn't null, then I need to do a couple things, right? So if it is null and I'm trying to remove from it, basically my work's already done, right? So I'm not going to worry about the else case. In another language, I might throw an exception or something to warn somebody, but for now, I'll just say, okay, if it's empty and I'm trying to remove from it, that's okay. I'm not going to worry about it, right? I just will make sure that the code is safe. So yes, that stops one issue. Second thing, right, is that memory deallocation. Now, as a rule in C, whenever we allocate memory, we want to deallocate later on. Thinking about our node creation steps, our node creation steps are basically requiring us to do a malloc, right, to create memory for a new node. Well, we need to basically mirror that with a call to free to get rid of that memory. So how do we do that? Well, one thought is I could do something like this. I could do free of front, right? But it won't work here because the problem is I've already moved front forward, so I can't use that here. And you might think, oh, hey, I can move it up top and that'll be better. Yes, but no. I can't do the free over here on front because I'm freeing front and then I'm using it, right? And we shouldn't free something and then use it. We need to free something only once we're done with it. So we need to fix that. Let's see. The way we'll fix it is actually the following. We'll create another variable, another contact node variable, and we'll call it temp. And we'll set that equal to front. So that's basically me writing down a note of where that frontmost node was stored in memory. Now I go down here and update front to move one forward. So that's fine. Down here, this is where I can have my free of temp. So temp was a variable that I used to remember that front node that I just forgot about. And so I still know about it. I don't depend on it anymore. It's fair game for me to free. Okay, so that should be our memory deallocation there. Last thing we need to do is basically return front, right? Return the front of that updated list. Okay, so this looks pretty good to me, right? We have our list coming in. If it's not empty, we basically save a reference to the front one, move the front one forward, and then remove the preserved reference. Okay, so that looks pretty good to me. So let's go over here and try this out. So we already know these are the three entries in our list. So let's actually try the following. After we add that second node, let's try doing a removal. So I'm going to do remove from list. Now, if this works properly, I should have a list where there is Wonder Bread, and then test gets added, and then test gets removed. Then over here, right, eventually we get to the end, right, and my hello gets added, right? So I should have Wonder Bread, hello. So let's start running this and see what we get. Hello, and then Wonder Bread, right? So test has been edited out. And if I want to, right, I can add some more things here, right? I could add another removal, right? And this would basically get rid of the Wonder Bread entry as well. So let's just try this really quick. Here we go. And now there's no more Wonder Bread. Okay, so that's what we got as far as removing a node from a linked list. Now, just to kind of finish this, one thought here is going to be the memory management in general for our list. So when I get over here and I do display, this list still has two nodes in it. So usually what we want to do is actually have another bit of functionality which is in charge of deallocating that remaining list. So sometimes you'll see something like this. Let's see. So deallocate list before we exit the program, and the way we deallocate, perhaps it's something like this. Well, list not equal null, right? Well, I still have a list. List equal remove front, right? So basically go through and delete one at a time, right? So that would be a good practice basically to make sure that your list is all emptied out and you don't have any leftover memory. You can of course mix this with the other code we did earlier for traversing. I'm going to have one function called delete list, right, which goes through loops and does it for you on every single thing in there. All right, so that's just kind of a note, right? Again, keep in mind whenever you have dynamic memory locations, you want to free it at a later point, right? You have to, if every malloc basically needs to be freed at some point in the future. All right, so that's all I got for this video. Hopefully you have a good idea now of how we would remove a node from the front of a list in C, as well as handling the memory allocation associated with it.